launched in the early days of Chandra, people believed that we're picking up all these amazing X-ray sources in small groups. And some of them are really, really bright, but they are not being seen in the radio. So the radio properties, the jet properties of the central galaxies would be very different. And here's a good example. XN62 was one of the earliest systems we studied. This is almost 20 years ago now, when we started looking at this, just after Chandra was launched. And you can see there's 3 galaxies in the middle. It's a very tiny group, very compact group. And here in the Chandra observation, you could see these cavities coming up, right? And when first the VLA map was made at 1.4 gigahertz, we could see a radio source in there, but somebody smoothed it a lot. Is very you can see that there was some indication something was happening, but really there was no radio emission at these frequencies. You turn on Chandra. Here's the Chandra map now. Now look at what GMRT gives you. GMRT at 610 megahertz gives you a beautiful map of these jets coming out. Exactly looks like what you see in these big clusters at hundreds of kiloparsecs. These are tiny. These are at the scale of a few kiloparsecs in the central galaxy of the small systems, right? And if you go to even lower frequencies, this is 240, and this is not even the upgraded GMRT. This is the previous version of the GMRT, and I'll show you upgraded GMRT, what they do. So you can actually start seeing radio jets that have multiple peaks, and I can predict that if a deeper image of this group is obtained by X-rays, we will see another cavity here. Now the radio is better than the X-rays. Yeah, this is what low frequencies can do, and LOFAR is only now. I mean, these are observations made 10 years ago now, 2007, 2008 by GMRT. Only now LOFAR is starting to observe systems like this, and you will soon see a lot appear, because LOFAR is a much more powerful telescope than GMRT. So XN62 showed us, first of all, that in various plots where you look at the energy balance between the central source and what happens on the gas itself, that these small groups fall on the same kinds of self-similar slopes, and you can see the same kind of heating and cooling happening in groups. But there are some really interesting differences, and this is what I wanted to say for the rest of today. The interesting differences are, first of all, you can see that there is not much gas in the centers of these groups. Like clusters, they are huge systems. They have quite a lot of gas in them. But the galaxies in the middle of these groups and the galaxies in the middle of the clusters can have the same kind of outbursts, right? With the same kind of radio energy. And if you have a radio outburst in the middle of surrounding the AGN of the central galaxy, it can actually go right through the gas and deposit its energy not in the group itself, somewhere else. The energy is lost, right? Then there are other things as well, which we are starting now to slowly see. And that is that we're also starting to see how in the central galaxies, in groups, the episodes of these outbursts, the radio outbursts, happen more and more often than in clusters. Here's a good example, NGC 5044. This is Chandra image from more than 10 years ago. You can see that's for the galaxy, NGC 1054, that 5044. The central galaxy, that's the optical boundary of the central little galaxy. And if you take the Chandra X-ray observation and do an unsharp mask, remove the smooth bit, you can see these nice little lovely cavities, 5 kiloparsec cavities underneath, right? And when people observed it with VLA, they didn't find a radio source. They found a point radio source somewhere. GMRT, our GMRT observation soon showed us that we can actually see extended emission towards these cavities. At 240, we found a lot of this stuff. These are jets, as you can see, going towards. But our surprise was, and now we've got some really lovely UGMRT data on this as well, that you see these radio blobs, and these seem to be broken off from these jets. And these have far higher spectral index. These are very steep spectrum, showing that these are much older than this. And by looking at them, so this was one of the first ones which gave us the indication that there are multiple outbursts going on in the central, because in groups interactions happen, galaxies interact more often, gas falls into the center of the galaxies far more often, and it is expected now, looking back and for hindsight, we can understand that in the centers of groups we will get much more, the AGN will be active much more often than in clusters. And so episodic outbursts happen in groups much more than in clusters. There's a big difference between clusters and groups. And this was one of the first cases in which we saw this happening. Now we are seeing this. Now we found systems in which we have evidence of even a third outburst. And then you can do H-alpha observations to see that how cold this gas is getting, and whether there are evidence of interactions with cold gas and star formation and stuff like that. Lots of stuff is happening, very similar to what you see in the Perseus cluster on very, very large scales. Imagine that these are, we are observing these things very small scales, kiloparsec scales, as opposed to hundreds of kiloparsecs in clusters, right? So the take-home point here is that there's AGN feedback going on similar to clusters, and you can see them at low frequencies much more. This is why GMRT, it was a unique selling point of GMRT, and now we will see this in LOFAR, and later on when SK starts working at low frequencies in Australia. These are going to be the most important things. People forget about clusters. I think people will actually look at groups, because that's where wonderful things can happen. Now, I'll give you another. I mean, one of the points that I want to emphasize today is that I told you that that clusters emit X-rays, and they cool by emitting thermal bremsstrahlung. There's a very important point that is different in groups. Almost all X-ray groups seem to have cool core systems, even though there's a lot of energy generation in going on in the central AGN. Initially, people thought that it's because the heating mechanism in groups is not very efficient. As I said, the jets can go through the gas and not deposit the energy. But we also realized, and here, look at this. Here's a simulation actually, but I can show you actual data as well of the X-ray X-ray emission from a group as a function of energy. It's just X-ray spectrum. And here's what the thermal bremsstrahlung of a 6 keV cluster like Perseus actually 10, say Coma or something like that, look like. And here's what 1 keV groups that are velocity dispersions of like 200 kilometers per second, 250 kilometers per second looks like. And you can see that a lot of emission happens in this region around 1 keV, and that's because of the ion lines. So groups seem to be cooling not because of just thermal bremsstrahlung continuum emission, but it actually has line cooling going on. It's the emission lines that are more efficient at cooling groups. That gives a completely different perspective to how groups behave, and that is why groups cool very fast. The cooling time is very short, and you can see that the behavior of gas cooling in groups is very different to that in clusters. Now it's very interesting. Now think of the life of a galaxy. I'm a galaxy. I formed on the cosmic web on one of the filaments. I'm in a small group. My group merges with another group. Then they merge with another group. They turn into these large clusters, right? And as you go along, the galaxies that are involved in these groups see very different environments. They see different heating and cooling mechanisms. And at the end, people will study the big clusters that are easier to observe, but the heating and the cooling that will go on there. But on the way, the galaxy has seen all these things where actually groups will all be cool core groups. The heating will not be very efficient. And here are some of the things that we are now discovering from various interesting things. For example, there is this whole problem to find where the baryons are in the universe, because you have from Planck or something like that from cosmology, you know that the baryon fraction, this is omega baryons, is of the order of 16%. But where are these baryons? I told you that if you look at groups or clusters, there's more baryons in the intergalactic medium, in the hot intergalactic medium than in the stars. True. But even then, that doesn't give you the entire baryon count that you need from the universe. And it turns out that the mass fraction of hot gas in groups are lower than in clusters. So where is this gas going? It cools so efficiently. It's not in the hot gas. It's in the cool parts. So we need to look at the cool gas. And the problem is that looking at cool gas requires technology that we don't always have. We don't have, for example, we cannot detect 10 to the power 5 degrees gas yet. Yeah, because they fall between the ultraviolet and the optical detectors that we have. So group physics is very difficult to observe right now in some parts of the crucial places where the energetics need to be studied. So this is a message I want to give you, that it is easier to study clusters. Groups are very difficult to study, but they are where most of the mass is in the universe, in the small groups. And there's still this big puzzle of where the baryons are. This is where the small groups are, where I'm talking about, and you can see it's far short of the omega baryons that we find from cosmology. But in clusters, we seem to find most of the baryons. And the other thing is, we find that this new way of feedback, which is called bubbling feedback, which means that in the central galaxies create jets, transfer energy to the rest of the system in more outbursts, and it's almost continuous in some cases, and in some cases it happens very often. In clusters, the central galaxy would have a jet episode or a radio outburst episode once every 10 to the power 8 years, or a few times 10 to 8 years. In groups, that might happen far more often, and in some cases it will be continuous. So, and that's very interesting. Some groups have very, very powerful central radio galaxies, as powerful as cluster galaxies. However, the energy transfer is not always very, very efficient. So, the last few minutes, I'm just going to talk about what we've been doing to figure out, in order to study these groups, we really need unbiased systems. You can't. I gave you some nice examples, and they're anecdotal. I can pick groups and show you nice pictures. They don't tell you what statistically the claims that I've been making. I've been making claims like groups are not very efficient in heating. There are quite a lot of different temperature phases in groups and things like that, things that are very general. And the baryon exists at all kinds of temperatures in groups, but not in clusters. But these are things that you can say from particular examples, but you really need to do a systematic study to find out how to find such, how to quantify this. And I'll spend the last 5 minutes talking about this survey called CLOGS that we've been doing for a long time. We looked at optically selected groups. You can't have X-ray selected groups. You can't have radio selected groups. Looked at optically selected groups, nearby groups. These are all closer than about 80 megaparsecs. And we selected them initially. This is the original CLOGS survey, of which now 4 or 5 papers have come out, and we are now extending that. But the original CLOGS survey essentially has 4 to 10 members. Above 10 members, it becomes a cluster. 4 to 10 members of the size of the Milky Way, and at least one elliptical galaxy amongst them. because otherwise we couldn't convince the Chandra time allocation committee to give us time, because they would say there's no galaxy, there will be no X-ray emissions. And then we studied all of them. We got 100, we got a 50 groups. Now we have another 100, but the original clock sample was 50 groups, and we observed them with Chandra, XMM, and GMRT. This was a PhD thesis of my student Konstantinos, who was here as a postdoc in IUCAA for several years, and now is in South Africa. And my postdoc was Ian Sullivan, who is now at the CFA at Harvard. And he did the X-ray work, and we put them together, and we looked at all these wonderful. So, and from this, these things went on over 10 years. And finally, over the last few years, we are slowly publishing the results. We have radio for all the 50 groups. We at various frequencies. We have CO emission maps from ERAM. We have H-alpha from, and Muse IFU now of many of these, and things like that. And I'll show you just a couple of quick, interesting results. I know we are running late. The interesting thing here was, so we optically selected unbiased sample of groups. We took all groups that are out to 80 megaparsecs, which have 4 to 10 galaxies. We selected them, and we had a declination cut. Otherwise, we couldn't use GMRT. So we that's all we did. We find now that, so now I can tell you statistics of groups because this is an unbiased sample. We find that they have a temperature range of such and such. 50% of them, we found X-ray emission in them. You know, our local group, which has 2 galaxies, does not have any X-ray emission that we've detected, right? So it is not clear that whether groups have X-rays. And we only started seeing these when Chandra and XMM went up. Now we know, because we have both Chandra and XMM data on these groups. They're very, very interesting systems. And I already showed you lots of pictures of them at the beginning. And within them, 30% of them have galaxies themselves have X-ray emission. And so that kind of stuff I can tell you. I can also tell you that the thermal balance you see, these are all lovely. This, for example, is one of our small groups, which has a 4C source in the middle, very, very bright source. And you can see that if you look at the balance between the power in the cavities, which is the cause of the jet punching a hole in there, and the luminosity of the power that's lost, you can see that these dots are from clusters. They fall in the same kind of relations, except for a few. And these are cases in which we can see the jets punching through and not really depositing the, like here, for example, the jets punching through the diffuse X-ray gas and really not depositing the emission there. Very interesting. So one of the things we get out of doing a survey like this is we can publish a paper on each group. Each group has an individual identity. And we've been doing this. We've been already written about 6 or 7 papers on individual systems because they are themselves very, very interesting. Groups have faces. These names mean something to me, whereas in clusters, all clusters look the same. We do quite a lot we find cool molecular gas at the centers of these groups that now would be related to star formation, right? So we can see, actually, this is how galaxies grow in small systems. In big clusters, the central galaxies are not growing by star formation anymore because the AGN is blowing all the hot gas away. The gas, blowing the cold gas into making them either hot or blowing it away. Whereas in these cool systems, all groups have cool cores, and the gas cools down to temperatures in which they can form stars. That's how galaxies grow. Galaxies grow in these small systems. They would not grow if they formed in clusters. And we can look at the molecular gas and look at all this stuff. We can see spectacular H-alpha filaments. We've been starting now working with ALMA to look at the H-alpha in the middle of these groups, some of them, and trying to find links between the gas that's cold enough or on the way to be cool enough to form stars in the middles of these systems. So that's what I wanted to say today. Based on these very interesting stuff that's going on, looking at multi-wavelength observations of galaxy groups, what we can now say is that groups, if you know where to look, 40 to 50% of galaxy groups have 50% have X-ray emission, and in prior surveys you hadn't seen them because they are harder to detect, and now with powerful X-ray telescopes you can detect them. And once you look at the X-ray morphology of these systems, you can understand what else is going on in them. And then by looking at the H1, the CO, H alpha, you can connect to the star formation bit. And by looking at the continuum emission at low frequencies, you can connect how the AGN plays an important role in the evolution of the hot gas that will become the dominant baryon component in the universe. And this just opens up a lot of possibilities for future observatories that are coming up, because we need much more powerful telescopes to observe these little systems. But that's where the fun is. I'm going to end there. Thank you very much.
Thank you, Professor Raichaudhuri, for the wonderful talk. Galaxies, of course, always fascinate us, and you have discussed about the interesting features in an equally interesting manner. So now I think we can take some comments and questions. So I can see one question on the chat box. So could you please have a look, or shall I read it aloud?
No, I can read it.
Okay.
Okay, so is it true that in future the Andromeda Galaxy and the Milky Way will collide? And if that happens, what will happen to Sagittarius, etc.? Yes, of course, this is not something I talked about today. The orbit of the galaxy and the Milky Way was my first chapter of my PhD thesis, actually. It was a long time ago. And to work out how they would, what time they would take to come together, they will collide, because it turns out that the orbit of our galaxy and Andromeda are on a straight line, and there is no significant transverse motion there. There's not much angular momentum. Otherwise, they would go around each other, and but they aren't. They are coming towards. And I showed in one of my papers earlier, and on the basis of that, there's a lovely simulation which you go on the web. You can find on YouTube by John Dubinsky, who's done a simulation of what will happen, what they will look like. And actually, he does quite a lot of detailed simulation given what we know about the dark matter halo of the two galaxies and the stars, what they will look like. Spectacular stuff. What will happen is that, as you know, stars don't collide. Stars are very tiny compared to the spacing between them. So when two systems collide, it's the gas that collides. And the stars don't collide, they go through them. So if you look at, and I wish I had it on handy to show you very nicely, what will happen is that the stars will go through, the gas will collide, and slowly they will come back on each other and merge. They will merge into one system. So what will happen to the central black hole? We see this in many galaxies now. We know at least 3 or 4 Chandra images of galaxies in which we can see 2 black holes in the center. And these are all seen in merging galaxies. Moushami Dash's recent work, you might have heard and seen the papers, where they discovered lovely examples of this. So this is what's going to happen. Of course, Andromeda's central black hole would merge with ours, right? And we know what happens when black holes merge. They would emit gravitational waves, but we won't see them in LIGO because the supermassive black hole merger actually results in gravitational waves that are in a completely different frequency range than LIGO. So we'll have to wait till LISA goes up in the satellite gravitational wave detectors to actually find the kinds of things that happen when supermassive black holes merge. And so our 2 black holes will merge, yes. So thank you for asking this question. This wasn't really related to what I was talking about today, but yes. Any other question?
Hello, sir. Am I audible?
Yes.
Yes.
Go ahead.
Okay, so one of your slides you have shown the contour maps of this cavity profile of a jet that is emitting from these radio sources, and you have said that you expect that after some point of time there is the cavity is moving. So can you tell the what is the source? Because cavity we know it is mostly forming at the center of this AGN. So if it is evolving and going away, I mean, what does it mean that from
Yeah,
this jet?
so yeah. So okay, so I should have explained this much more. What happens is that if you look at the think of it, the X-ray emitting gas as a continuous medium of plasma at 10 to the power 7 degrees that is in between the galaxies that fills the central bit of the dark matter potential of the cluster. Okay, and at the center we have the AGN that's sitting there, and it has an outburst. The outburst, of course, doesn't come from inside the black hole, but from the surrounding of the black hole. And the outburst is relativistic plasma, which comes out in jets, and it consists of negatively and positively charged particles, and they're coming into this system. Now, as it does that, it displaces this hot gas and creates these bubbles, right? Now, the bubbles then rise through this medium due to buoyancy. These are buoyant bubbles. What happens if you blow a bubble in at the bottom of a fluid? They will rise due to buoyancy, right? That's how, for
Yes.
example, you see when you heat water, you see the bubbles coming up. So these will rise because the gas, the intergalactic gas itself, has a pressure gradient, has a temperature gradient, etc. All that is there, but it has a density gradient as well, denser at the bottom, and so these bubbles will rise through the medium in and these have size, particularly in groups. The bubbles themselves have small size compared to the extent of the um, of the of the IgM, and so they will rise. As they rise, they are going into regions where pressure is smaller, and so they expand, right? And as they expand, their volume becomes larger, and they are doing work on the intergalactic medium. This is essentially the enthalpy of this system. The total amount of energy that they can exchange due to this is 4 PV. You can work that out, the enthalpy of
Okay.
a point bubble. 4 PV, where P is the pressure at any point, and V is the volume of that bubble. So that's quite a lot of energy. And at the center where P is much larger in this system, there's quite a lot of energy being exchanged. So these are buoyant bubbles. Now the questions are asked about, how many bubbles are there? We can only see the biggest ones, and in groups we actually can't see these bubbles. They're so tiny that these cavities, it is very hard to find them. I showed you some examples, but those are the best examples. In clusters, you see them everywhere, right? Because they're much bigger and they're much easier to find. But once we know the relation between the jet power and the bubble power, even if we can't find the bubble, I mean, how these are magnified through bubbles, we can infer that. We can actually, even if you don't see the bubbles, we can infer how the energy is being transferred, etc., by just looking at the radio energy that's coming out. And that's what's done mostly now.
Okay. Okay. Thank you, sir.
Anybody else? If not, I'll hand you back to the chairperson and go on to what we have to do.
Yeah, so I don't see any other questions even on the chat box. So uh, let us thank the speaker, Professor Somak Rai Chaudhuri, once again for the wonderful special lecture. Let us also thank all the other speakers of the session once again. So now I would like to hand over the mic to the host, Dr. Shanjit Singh. He can take over, and then there will be the next proceedings. Thank you.
Thank you, Dr. Momold, for coordinating this afternoon sessions very nicely. So thank you again. And again, so I'd like to thanks to Professor Somak for being the part of NIMA 7 and your wonderful talk presented and interesting interactions with the participants. So, so with one permission from Ranjit Mishra, so shall I
Yes.
continue or hand over? Yeah, you hand over to your.
Ranjit, first you can make your summary, like you said you would do, and then we go
Oh,
ahead.
oh, okay. So, thank you for allowing me to highlight a quick summary of NIMA 7 editions. So I'm sorry I could not make a PowerPoint. So in words, it is okay, sir?
Yes, yes, of course. Go ahead.
Okay, so yes, as you know, due to prevailing situations of this COVID-19, so NIMA 7th edition, which was supposed to happen in a hybrid mode, has been taken place completely in online modes. So this NIMA 7 edition is organized, yes, in online mode from 27 to 29th January of 2022. So in the Department of Physics, Rajagandhi University, in association with the Inter-University Center for Astronomy and Astrophysics, IUCAA Pune, and with the constant support from other institutes and universities. So this time, I on the behalf of this organizing committee, so would like to thanks all who directly and indirectly support us at the time of great needs. So, I should not miss to mention this thing also in the inaugural function. Our Honorable Vice Chancellors, Professor Saket Kushwaha and Pro Vice Chancellor Professor Amitabh, and the registers, Dr. Navam Tadar, Rikams, Dean of Basic Science, Professor Sanjay Kumar, then Head of Department Physics, Professor Pratik Kumar Kalitars of this university, Rajagandhi Universities, and the IUCAA directors, STEM Professor Somak Rai Chaudhuri, Grace Pangsand. So again, I, on the behalf of this organic committee, again, like to thank all the distinguished dignitaries who were present in our functions for being the part of NIMA 7 editions. 7 edition annual programs, and for your constant inspiration to go ahead the NIMA 7 and for enlightening and eyes opening us on the recent trends of the astronomy and astrophysics. So for the 3 days and NIMA 7 editions, so altogether 76 applicants, but we see maximum in the beginning. Yes, it was around 70. Now today I see here only 41. So as found in the Google form are received for attending NIMA 7th edition from the northeastern states, mainly Assam, Arunachal Pradesh, okay, and Meghalaya, Manipur, and Mitzoram. So out of all the participants, 16 participants, including professors, gave the oral presentations on their current research work. So and we arranged 2 sessions, morning sessions and evening sessions in all the 3 days in NIMA 7th. So in the first day, just after the inaugural programs, we had 2 talk in the morning session. One speech and talks given by the Professor Ajit K. Kembabi, IUCAA, and 45 minutes talks by Dr. Indu. So in the afternoon sessions on the first day, so we kept 6 speakers. So they presented their oral presentations and followed by the question and answer in all the 6 oral presentations from participants. So in the second days, we gave in the morning sessions 6 speakers and the 6 oral speakers in the afternoon session. So we had a good and fruitful discussions on our current work. So in the third day, we had 8 number of speakers. So today, had difficult times really to manage the time schedules apart from the question and answer session times. So this morning, so apart from that, the 2 technical sessions here, so at 11 hour, because of the health problem and the network issue, so declined to take over the sessions here, and so it compels me to take, and then somehow face some difficulties and difficult times. So in the afternoon sessions, yes, we enjoyed 3 oral talk and 1 speech and talk just finished, concluded from the IUCAA directors. And overall, we had the fruit discussion in the afternoon session as well. So for this, again, I would like to, on the behalf of the organizing committee, thanks especially all the professors for being the part of us, despite having their busy and the tight schedule, and others, and all the others participants for their or your online oral presentation and the participations. So 2 special talks were given by the 2 IUCAA professors, as you know, one in the first day and the other in the last day of NEMA 7th edition. So I hope we have got the good, useful knowledge, idea, and motivating, inspiring speech from special talk. So for this, I thanks to IUCAA professors, so namely Professor Ajit Kembabi and our IUCAA director Somal Rai Chaudhary. So and then the thanks for all the for your wonderful talk, and thank you, sir. So I should not forget to thanks my all colleagues of physics department at Rajagiri universities and from the various institutes and universities for their constant support and inspiration throughout the 3 days NEMA 7 editions. So for this, I thanks all once again. Lastly, I would like to thank all the technical staffs, research scholars, and the semester students for extending their help. We received well. We need much throughout the NEMA 7 editions. So with this, sir, I thank you all again for your kind attention. So I request Professor Ranjit Mishra to have some concluding remarks and to declare the some conclusions of the 3 days NEMA's 7 editions. So I hand over to Professor Ranjit Mishra. Thank you.
Thank you very, very much. Before Ranjiv takes up, can I ask you, Shanjit, has anybody taken a group photograph?
Yeah, sure. I was about to, request.
Can people turn on their cameras and actually take a group photograph?
Yes.
That'd be very nice. Thank you.
So I think Sagar Singh Gogoroi is also there. Sagar Singh, could you have? So I request all the participants to turn to video to have a group photo screenshot. Sagar Singh Gogoroi, you please take a skill shot next by next. You try to cover all.
I'm not getting everybody. Williams, I can do this too. Almost.
Sagar Singh Gogoroi? Sagar?
I don't think he's here. There's no.
So are you continuing to tag a screenshot? Okay. So because of the network connections, yes.
Quite wonderful to see everybody, because I mean, the entire through the 3 days, I haven't seen the participants at all. It's good to see at this one time. Thanks, Ranjiv. Please take over.
Okay, I know it's getting late in the notice. It's 4:20 right now. I've got 2 points to make, and I will quickly address them, and we'll go ahead. The first is I have a confession, and I really want to make this confession that I attended very little of this NEMA session, much more less than what I had intended to. Only at 3 or 4 talks I could manage in the things. And worst, more than just the fact that I was attended a few of them, even when I was attending, I must confess that several times my mind was distracted in other things, and I could not pay complete attention to the speakers and get the things out of them. And this is kind of natural because to give you an example, like I think it was yesterday or day before yesterday when we had a NEMA meeting, and then at the same time we were having a very important overall IUCAA meeting at IUCAA in afternoon, and at the same time there was a very important AstroSat ISRO meeting. So I had 3 devices trying to pull up and trying to see things, and since my mind doesn't parallel process that well, I just landed up not listening to anything at all in all 3. So earlier what would happen is, if I had actually come to NEMA out there, I would simply write, no matter how important a meeting is, I would write down, I'm sorry, I am attending a meeting in Itanagar. I cannot attend the meeting there. That's it, period, over, and I will have had my full attention. So for all of you, if you face similar problems like me, I would say that you are not alone. I did face this problem, so I guess some of you would have also faced the same problem. The second small point which I think I should make is that I'm extremely happy to note that I think I know less than 10 people here. 10 or 12 people here. I think maybe about 12 to 12. And it's not that I'm getting old and senile and I'm forgetting people. No. That's not true. I remember a lot of people out there. It's just that I'm very happy to know that most of the people here I don't know. That means we are seeing new generations coming up. NEMA is active and will live for a longer time. And this is something very good. I wish I was there so that next time I would have been able to recognize all of you by face again. But that comes to my, that is only the second point of it. Now, before we go into anything else on that thing, I want to definitely make sure that there is continuity. We are going to continue, and I should not say this, should not jinx myself. I think the next one will be offline. Let's hope for that one, that we must have the next one offline. And as I say, optimism is a good thing. We'll keep it on. The next NEMA will be offline. So the first thing to discuss is where and who thing is going to happen the next NEMA. So just to wind up the thing, yes, I can see Ablu suddenly come up in the screen. All right, I remember Ablu, I remember that we had decided that about a year and a half ago that after the Itanagar one, we will have this in Manipur. Ablu, what do you think about it right now? Can you?
Yeah, next must be in Manipur, in Imphal.
Okay. Anybody else has,
yes, we are also in University of Science and Technology, Meghalaya, also interested.
Yes. Meghalaya is also, so Shillong is something which we should also be doing.
So Meghalaya is very close to the city of Guwahati. The 9th mile CRP camp, so which is very well connected in communication, and as well also accommodation also is very good. So we are ready, sir.
Yeah, you're ready. Great. I agree with that. But Ablu, you are ready too?
Yeah. Yes, definitely. I've been waiting.
Yeah.
Sir, sir, because I think in 23rd Manipur University will be going to held in Pane also, I think. So, right?
I'm sorry? No, I mean, actually, we haven't had one in Manipur for a very long time, I think. That is one point. There is one thing going off in favor of Manipur compared to you, President, is that we have had a NEMA in Meghalaya. In which one was it? The third one, right?
Yes, the third one, NEMA 3.
NEMA 3 was held in Meghalaya at that time. And while we have not had a thing in Manipur, but what I really suggest is that if things are really going to improve like this, we should hold offline things much more often than ever. So I was wondering what kind of a date are we looking at? We are probably looking at something like November, December, right? This November, December, or October, even if it is practical.
This year.
This year. Ablu, is that okay?
This year?
Yes, this year, 22.
Yes, this year.
This one is 21's one that is happening.
Will not there be this one? What about there will be chances of doing it online because of this COVID problem?
No. See, I think if we can't hold a meeting in October, November 2022 offline, there's a high probability we will not be able to hold it offline even 23. So if things don't improve in 6-7 months, we are not going to be much better later, right?
Okay.
But Abdul, what I was thinking is, let us assume that we can do it in October, November. Would that be a okay place, okay time to hold it in?
Yeah, it will be okay. There won't be. I think there would be much problem if COVID problem is not there, then there won't be a problem at all.
Oh, the reason for Faizuddin I was thinking is, suppose we can't hold it in. It will be better to hold the NEMA if it is offline and everything like that. During the winter in Manipur and in the summer in this thing, Meghalaya.
This summer.
That would be a more logical thing to do. I think that Meghalaya in the summer would be very, very encouraging for people to come in. So, as we decided that, okay, first of all, Santa Baba, what do you think? Do you think that holding
I mean,
in October, November is good, or
I think the mode is maybe subjective because we do not know the COVID situation, but it should happen in every year. For example, in 2021, we could not manage it. So whatever we are happening now, it should be it should happen in 2021. So this year, definitely we should have one.
I also agree with
And I remember, I think we decided to have in Manipur, if I'm not wrong.
Yes. I mean, we had committed. That is true.
Yeah.
I completely agree that. In fact, there was a big negotiation between Ablu and Sanjeet, and we had promised Ablu that we will give the next one to him. So my suggestion would be, if everybody thinks this, that if we have one in October, November in Manipur, then we can, in fact, quickly follow one more in this next August or September, before in Meghalaya. Would that be fine?
Yes, sir. Yes, sir.
That I think. Who else is?
Ranjeev, can I say something?
Yes.
In the inaugural session, the Vice Chancellor made a very interesting point. He said, and this is commitment, I hope Sanjeet is listening. He said that if the COVID goes away, we will have a NEMA 7.5 here in person.
7.1.
7.1. 7.5. Something like that. So you can think about whether to actually break up things into online and offline modes. But that might be a very interesting way to do it. I don't know how COVID is going to go.
Yes.
Actually, I want this one, the session to be offline, not online.
I agree. So okay, Ablu, let's take a stock this way. That we have time right now. Let us say we in July, August.
Okay.
We will take stock of this, and if you I understand that you may not be, you don't want to do it online, right?
Yes,
Ablu?
yes.
Right. So let's take a stock in July, August. If we find that we are unable to do a November, December, October, November, December kind of a NEMA 8 offline, then we'll just think of making another online thing in October, November, and then go to you after that.
Oh, okay, that's fine.
Okay. Fazludin, maybe you could help us at that time, that in case we land up again in online, maybe it'll be easier for you to handle it.
Okay, sir.
And then we could decide in that thing. Who else? Himadri, is that fine? Are you there?
Yeah, it is fine.
Okay.
What you are discussing, it is fine.
So we can do that. I had one more point in this thing, is that we need to involve more of the states. And once, this time I could not do it very effectively. I again apologized. Next time I will try to work out more about how people can join in and get from other states involved, like Nagaland and Mizoram, for example.
And
I know
Sikkim
there are people, yes, to see where people are not working, and I also think that there is some issues. We have people who are working in Nagaland and Mizoram, and they have not been somehow not getting corrected here. And I don't mean to see it in a bad way. See, what happens is that my understanding is some people don't easily get it. So you have to like prompt them, nudge them, and I will try and do that in the whole thing. And again, I would like to request Shomut for something which I always thought would be we would like to do, but we've not done, is we would like some kind of a more official definition of NEMA to make it go into a next level. And this would require either working through the DSTs of the state level DSTs of each of the states, or through the Northeast Council as we had thought about earlier. But now that we don't have, when we really go offline, it will make sense to try to see if you can get some kind of funding from that side. Or recognition in the terms of the Northeast Council and make it more. Perhaps we can invite some important people over the next NEMA to give it a more official recognition. Apart from that, is that okay?
Yeah. I think that's actually Faizuddin's microphone is creating a noise. Can you mute yourself, Ma? Yeah, right. Thank you. So I said this before, and I think this would be actually very important. It won't be difficult. I need a good proposal, and there is quite a lot of interest in holding more and more meetings of involving Northeastern scientists in the Northeast, and I think it'll be we can easily take this. We need a coherent proposal from the people involved here to where are you going to spend this money, and how often are you going to do this, and things like that, and just a kind of, we can already show that there are 100 people participating here, but how to increase participation and how to increase not just participation but the activities more and more there. Easily doable. Please work towards producing a proposal of this form.
So my general basic idea was to ask for financial help for NEMA itself, a little bit, so that you can get and invite somebody to come to NEMA, some DST level person or some, so that they're aware that we are doing this in larger ground.
Yes.
So the next NEMA, I think hopefully we can try and broadcast it more and tell people that this is
actually your idea of doing this twice a year, a summer meeting and a winter meeting, is also very good. I mean, looking at the expanding participation here, it would be quite nice, and we can even divide up subjects to some extent. If you think that the same people wouldn't have to give same talks, but clearly the number of people participating is very good. I didn't mean Faizuddin to switch off everything. I don't know. I didn't ask it. I just your microphone was creating a feedback. But I think having a Meghalaya meeting soon after the next meeting would be quite good. I think if it happens once a year, often what happens is that there is not enough momentum built up. But now that 70, 80 people are participating in something like this, and if somebody, for example, can't go to a winter meeting, they can go to a summer meeting and things like that. Think about doing something like that.
Yes, I think we can maintain it to at least for the next 1.5 years or so, at the rate of 7-8 months instead of 12 months or 6 months, kind of a momentum, because a lot of people would like to come in. And Sanjit, did you remind me how many people filled the form again? Sanjit?
So 76.
76 people.
Yeah, in the Google form, he is a pound.
Yes, and this also we we are also banking upon the MSc people also, right? MSc projects. Or
Yeah, sir. The problem is this. So experience first time. So because of these online programs, so sometimes the students join and then the exit leave like that because they are living in the deep area and then
yes,
facing the network problems. So they
yes,
inform me. So and then they excuse us really for such a
yeah,
thing. So I experienced these things for me really for first time. So
yes.
this is one of the inconvenience for making the happen online, I think.
Absolutely. But my point was that if we actually expand out more and like we should previously do, also take in talks by people who are doing their MSc projects in astronomy, we would have a quite a larger number, right? Isn't it true, Santapata, or you and Himadri? We do have a lot of MSc projects also, right?
Yes, in our department, basically in fourth semester, we have projects and around 25 students are there in
That's
MSc
it.
Astrophysics. Okay, so I
So
think around 20 students can join, which it did in our when NEMA was held in our university. Around 10 to 12 group actually joined for this presentation. So I think it is possible.
yeah, I saw Munmun's chat message. Yes, of course. As we expand out, we should have things of different topics and related ones, and this is something which we can also do in the long run. And also, I would like to remind you that in the Northeast was also been one of our main centers for doing workshops, and of course, workshops are much more difficult to do online, and so I also look forward as things become normal. We'll encourage you to we have to get back to our regular workshop mode, and many of the people, as you know, were introduced into astronomy through these workshops. So we have to get back on that one as soon as we can. So this is apart from NEMA. So if any of you want to hold workshops as soon as things becomes normal, please do contact me. We'll try to do something about it in different topics. Also, we need, like Munmun says, like we need workshops in astroparticle physics. We need workshops in several other things to work that out. Okay.
Actually, I was thinking to organize a workshop on AstroSet in our university.
Okay,
So because, yeah, so very soon I'll be going to submit a proposal, and if it can be done offline, then it will be better.
yeah. We'll take the proposal, we'll look at it, and then of course we will check everything according to subjected to the present condition at that time when you're holding the workshop. So, I mean, to give you example, there was, I think, a workshop scheduled in Kerala on February 19, which we had done and approved from here. But I don't think it's going to happen. But not going to happen means we'll just postpone it. We have made the arrangements for a workshop, and we'll just postpone it to a time when we can actually hold a workshop. So
okay, so that workshop will be limited to Northeast, or anyone can join from any part of the country?
That depends on your logistics, Modi, how you can handle such things. How many people you will get from. Usually, what my experience is that you will get so overwhelmed from just Northeast people.
Okay.
Then, but it also makes sense to have it only for Northeast, because other people can go to other areas much more easily in India. The Northeast people have a really tough time traveling.
Exactly, this is the main problem with all of us.
So that is why I think if you have a workshop in the Northeast, I would not limit it, but give preference to Northeast people.
Okay.
That is, because I know it takes a long time to travel within the Northeast itself, and not to mention how coming out and going any other place. So, okay, anything else anybody would like to mention?
I was thinking, I mean, it's a long thing we discuss in corridors, since Samugda is here and you are also here. Just like it, can we do something like ACRC school in astrophysics? I mean, I mean, so that we can really train the young generation.
That's right. That's right. In fact, it
I
see.
mean, in the high energy people, they are religiously doing it since our childhood. But in astronomy, this effort is really not been there.
No, I mean we have had astronomy schools before. I mean, even I think last
We
year.
organized one. We organized one in Tezpur University.
Actually, it has to be a kind of regular event, just like we are religiously organizing NEMA. Whatever is happening doesn't matter, we will organize it. So it should be something like that. I personally feel that if I am to really train people, not just by inviting them to present their work, if you want to really train them, that Himatri is saying that in AstroSat workshop kind of thing. So with the multiple components from the astronomy point of view, let's say maybe a 2 weeks workshop or something like that. I mean, I think it will be more effective.
I think that's a very good idea, because I think the Tezpur one, it was, I remember, it focused on observational astrophysics. I think was very good. The one thing that you're talking about is getting a proposal to DST or SERB. You can make that a part, an annual astrophysics workshop.
Something like that, yes.
Right, and so this will be different from NEMA. We're talking of twice a year. One of them could be a workshop, and the workshop is totally different from NEMA, right? It's more educational, more pedagogic, and things like that.
In fact,
let's do as integral part of this proposal to DST or SERB, have a CERB school in the Northeast every year in astrophysics. That would be great.
Absolutely, absolutely. In fact, Sandra, the only thing I think it restricts, and what has not happened is not that right, is that 2 weeks or which comes to 2 or 3 weeks commitment for somebody is quite a bit, especially for organizers, and that is what I feel has been happening for. But I'm completely for it that we should have a 2 weeks long workshop, because that's the time when you can learn. And we've got fantastic ideas of how to do this, and also please consider this seriously, and we can get it done.
Hello, may I say something?
Yes, Vijay.
Yeah, actually, SERB school has to be for 21 days,
That's
3
right.
weeks. So that's the criteria of SERB school. And when we organized in 2017, then DST person Amitabh Roy, he told me that they are hardly receiving any proposal for SERB school in astronomy. So DST was also very happy that we applied for one. And it was sanctioned very easily. So I think, Santa Brata, if you apply, it will be passed very easily. At least that's what Dr. Amitabh Roy told me when we were organizing our school.
If you remember, when Dr. Saikia was Vice Chancellor of Cotton College.
Yes, sir. Yeah.
He held 2 or 3 of these workshops.
Summer school, sir.
They were 14-day long, so there's almost like a CERB school, and I taught in all of them. They were absolutely fantastic, and so much demand there was, right? So I think there will be a demand if you can make that into a CERB school. That would be fantastic. So that and they can go around. I think doing it for 21 days, people can get a little afraid of organizing.
Yeah, true.
But if you go around, there are lots of people who are. I mean, if you remember, in your case also, you had what, 30 participants or something like that?
40 participants, because that is the criteria of SERB school. It has to be for 21 days and 40 participants. Yeah.
And if necessary, we can bring in students from outside the Northeast if you don't think that there will be 40 people there. But first preference will be given to students who are studying in the Northeast region. You can start that, and judging by the demand you had in your school and in the Cotton College schools, I think there will be quite a lot of demand.
Yeah, of course. Yeah, true.
In general, I think every format we should explore. Even if you think 21 days is too long for you to commit for some reason, because we're teaching and all kinds of activities. But that doesn't mean we should not have a 3-day one also. which you can easily do with your timing. And so those things we are, from 3 days to 21 days, we can span the whole thing. We can check out what are the different kinds of workshops we can do. It really looks at initiatives. We can definitely do this.
Ranjit, 21-day workshop or a 3-day workshop all seems like a dream right now, right? We are sitting inside our houses for 2 years now.
Yes.
I really love to dream about a 21-day workshop. It would be fantastic. The way to organize such a thing is that, to break it up into chunks so that lecturers who are coming do not need to spend more than 4 or 5 days at a time. And this can easily be done. It's a huge pressure on the organizer.
In fact, the problem is not with the lecturers. In fact, I can get people who will commit for 1 week very easily, and they will do it properly. But I know, by the time the 5 days workshop happens, I know I sometimes pity the organizers, coordinators who go through that thing when I leave, usually I'm the last person to leave. I can see the happiness in their face when I'm that the whole people are gone. And that too is only 5 days. 21 days take it all, but it's a great thing. One should do this. And
even
especially if you come together, few of you come together, then you can share the load thing, and it can be done very well. Yeah. Okay. Anything else? Anyone? Okay.
Ranjit,
Yes, sir.
For funding from the like NAC, you once proposed, suggested to take the letters from help from MPs, MPs also. So I think this time, we can write. I think I have some friends who know this. Two of the MPs in Manipur.
Okay, good.
So,
we need such contacts.
Shall I try to talk to them?
Yes, sir. You see, all this thing takes a long time. Okay. So just I would suggest that you just put in a word right now, say that we are planning, and then slowly ramp it up as we go on. Wouldn't that be a right idea, Shomak?
Yes, absolutely.
You start contacting them even though things are not concrete right now. You say we are planning an NEMA in October, November. Just give them a heads up. And as things improve by July, August, when you're clearer, you really approach them and tell them that this is happening.
Okay.
That could be a very, very... Anything else? Okay, so this is a time when we should thank Sanjit for organizing this.
That's what he has done. It was enormous.
I hope your health is okay. I heard your Vice Chancellor mention that you were actually COVID positive recently, and you did so much work to do this in between. Thank you very much for organizing this.
Yeah, thank you, sir. So still in the home isolation state still. So after 10 days, I tested COVID positive again after 10 days.
Oh my God.
So yeah, it's going on Monday. I will test it again. So
I hope your health is okay.
Yes,
let me put my official complaint here. I had actually tried very hard to tell Sanjit to call it off. I told him, look, these NEMAs are not that important. Just call it off. We will postpone it, call it off. We'll do that. But he just simply refused to listen to me. So that's I just want to put that officially down there.
Yeah. So at the time also, our honorable Vice Chancellor was pushing me, what really, to move and go ahead. So I could not stop at the time, sir. So.
Okay. And the worst thing in all these online things is that you can't either complain or thank about the food arrangements. So those things we can't talk about. So Hopefully next time we'll have our complaints and praises of the food and accommodation level at that. Okay. So
I would like to add the one more point that I forgot to cite, that our from our university side also, our honorable vice chancellor sanctions so around 7,600 for financial as a financial help for organizing this NIMAS event. So I'm thankful, very thankful and grateful to our honorable vice chancellors for this.
Yes. Okay. Has anybody else any special comments to make right now before we wind up?
No, sir.
Okay. All right. Shomak, any last words?
Thanks. I think this was an excellent event, and I'm very happy that you could do it. Let's hope we meet soon. We're getting tired of online meetings, and a mixed mode doesn't work. So it's either completely online or completely offline. Let's hope for a completely offline one day.
Yes.
So I wish the next time to have a physical NIMA meets in Impal next time.
Yes.
Thank you, Bob. Thank you, everybody.
Okay.
Okay.
Thanks.
Thank you all.
Thank you.
Thank you.
Thank you.
Okay. All right. Bye, guys.
Thank you. Okay, bye-bye.
Bye.
Thank you, sir.
Thank you.